You are a data-making machine. As you walk down a sidewalk, catch a bus, or stop for a coffee, you emit an invisible digital footprint into the city around you. This constant stream of location pings, transit card swipes, and social media check-ins is what researchers call urban exhaust. Harvesting that exhaust is the foundation of a rapidly expanding field called urban analytics. It combines computer science, statistical physics, and city planning to gather up all those digital breadcrumbs and use them to shape the physical environment. Before this massive wave of digital information, city planners trying to figure out where people would go had to rely on deductive math and equilibrium models. They built equations to simulate traffic and migration, but ultimately it was highly educated guesswork. Today, we have spatiotemporal big data. Planners don't have to guess where people might move in theory, because our embedded sensors and mobile devices tell them exactly where we are moving right now, in real time. Moving from theoretical equations to live updating empirical science gives city governments the ability to closely monitor and optimize nearly every aspect of our daily lives. To use this information, data scientists translate the metropolis's physical chaos into a mathematical structure using spatial graph theory. Intersections become nodes, and connecting streets become edges. Analysts flood this topology with real-time movement data, unleashing algorithms to find patterns hidden within human circulation. This yields highly practical insights. A city can accurately map which specific neighborhoods are exposed to the worst air pollution, predict exact travel demand during rush hour, and optimize public transit routes. During the first year of the COVID-19 pandemic, epidemiologists relied heavily on aggregated mobile phone data to measure human movement. This allowed them to see exactly how well mobility restrictions worked to slow the virus's spread. When applied properly, data-driven optimization solves some of the most difficult logistical problems a city faces, but the trade-off is steep. To function, this system requires the absolute, constant visibility of all its inhabitants. The exact infrastructure built to make a city smart, the Wi-Fi sniffers, transit cards, and mobile networks, operates as a mass surveillance network. In the past, simply walking down a public sidewalk offered a basic expectation of privacy, a concept ethicists call contextual integrity. You were in public, but anonymous in the crowd. Ubiquitous sensing erases that anonymity entirely. Consider the traditional legal standard for wiretapping. To track a citizen, the government needed a warrant based on existing evidence. Passive sensor networks reverse that dynamic. Mass surveillance happens automatically, placing the burden entirely on the citizen to actively figure out how to opt out. We see the stakes clearly in Saudi Arabia's Absher smartphone app. On its surface, it operates as a standard portal for routine government services. However, the app includes a feature that tracks when a woman uses her passport and instantly sends a digital alert to her designated male guardian. Despite fierce objections from domestic violence advocates, Google refused to remove Absher from its App Store, arguing that it fully complied with their technical terms of service. A simple piece of civic software designed for bureaucratic convenience can seamlessly enforce a repressive status quo. Algorithms process numbers, but they do not account for human dignity. If we rely strictly on data-driven planning, we systematically exclude marginalized groups who lack internet access or smartphones because they leave no digital footprint for the models to see. Addressing this requires a framework researchers call critical urban analytics. It starts with a simple recognition. Urban data is never neutral. Collecting, analyzing, and acting on information is inherently an exercise of social and political power. The goal of this critical approach is epistemic equality. It is a deliberate effort to rebalance the severe power asymmetry between the massive technology companies harvesting the information and the everyday citizens generating it. The first requirement is strict corporate governance. People must have a legally protected right to know exactly what data they are creating, how it is being used, and who is purchasing it. The second step relies on education. Basic programming and data literacy must be integrated into K-12 schooling, ensuring the next generation actually understands how ambient sensors and algorithms operate in their own neighborhoods. Finally, institutions need to build open data systems. Instead of sequestering insights exclusively inside private tech giants, large-scale data must be safely anonymized and made accessible, allowing local communities to leverage analytics for their own needs. When transparency and control are returned to the public, the dynamic flips. We cease to be passive subjects of a massive surveillance network and instead become active architects of a more equitable city.